Chemistry is often called the central science, one that enables further study across a wider range of disciplines. At the same time, chemistry can be a bit exclusive. We don't like to think of it in those terms, it's fairly uncomfortable, but we place such an emphasis and value on hands-on practical work, and we have quite rigid ideas about what must be taught in our degree programmes and how we must assess learning. We also make certain assumptions about what chemistry graduates will go on to do, and this sometimes leads to that many feel chemistry is not for them. At the moment, there's a lot of UK universities engaged in work to make their curriculum more inclusive through initiatives to decolonise the curriculum, become anti-racist institutions, and other projects to increase equity and accessibility. It can be difficult, though, to know where to start, particularly in the STEM disciplines. So we're going to look at the idea that chemistry must be for all, and that it's global, diverse, and fit for purpose. So, chemistry is global, so we've got a picture here, and your first response is probably, right, yep, it's Earth, it's from outer space. Look closer. In this image taken from the Apollo 17 mission, you can see Antarctica is at the top. And then we come down into Africa, you can see Madagascar, more or less in the centre of the globe, and down to North Africa. And this is a reminder that chemistry is both global, but also our worldview, the view of the maps and the views of the globe that put Europe in the centre of things is purely arbitrary. Now, I started thinking about all of this at a point where I developed a module on sustainable chemistry. So in 12-13 we developed this module. I was chemistry course director at the time at Keele Uni, and we were establishing several new programmes, our single honours programme and our MChem. And I led on the creation of a single honours only module that would bring together the global challenges, those modern problems that chemistry research was working on. So very much contextualised. But I wanted a module that would put chemistry in a broader context: social, economic, political and environmental. And in the early years of our sustainable chemistry, our philosophy is best summarised in this cartoon. We were reluctant in 12-13 to tackle climate change significantly, and we got pushback from students when we did. The first change in our thinking came in 15-16 when we delivered the module both in person to Keele students and via distance learning to Chinese students. If we fast forward to the 2019 version of the module, we've expanded the context of chemistry to put it very much in the global context. We expanded to address a wider range of United Nations Sustainable Development Goals, and we tick most of these off. But in 18-19 we started addressing content, context and assessment through a formal lens of decolonization. The work we did delivering this module through distance learning to Chinese students very much kick-started this work. And we had to address a key question: how do you teach sustainability via distance learning to a culture you barely know, and barely might even be an exaggeration? Well, the simple answer is you get students to teach you. So the first assignment we set the students was to produce a group project, to make a video describing sustainability and environmental issues on your campus or in their city. And this was only for the Chinese students, which was a complete missed opportunity. We should have had the Keele students do the same, and we should have facilitated sharing of the videos. But this was a pretty joyful assignment. The groups of Chinese students filmed themselves around their campus, highlighting good and poor environmental practice. One very memorable group interviewed bus drivers at the local bus depot, and they filmed themselves chasing after these bus drivers to ask what it was like to drive the hydrogen-powered bus. And they very kindly gave subtitled their videos where they did these kind of interviews so that I could understand. Assignment 2, we did manage to make the most of opportunity of having students on the module via distance learning in China and at home to Keele students. We just put them in groups and got them to discuss via social media and email, what does sustainability mean to you? And it turns out that what unites us is quite obviously far greater than what divides us. A lot of common ground was found between the students, comically mostly about who was teaching. That seemed to be the obvious common ground, but also the conversations veered in many unexpected directions into other aspects of culture. But one of the key things we struggled with was our curriculum was highly Eurocentric. Our analogies, the information we were providing about sustainability was all related to these Eurocentric practices. Which brings us to an idea of cultural accessibility. We had to ask some pretty serious questions about our analogies, our contextualisation, examples, stories and humour, and we had to ask ourselves, will these actually work for the majority of students? Or, framed another way, by using that analogy, that story, that context, who am I excluding? And a very basic example of this, I've grabbed some screenshots from the BBC Bite-Size revision website. This is the plum pudding model. And it shows the positive charge with the negative charges seated a bit like fruit in a plum pudding. J.J. Thomson proposed this. And there's a hyperlink, and it takes us to a bit of information that says the scientific idea that an atom is a sphere of positive charge with negatively charged electrons on it. I have to admit, I was a bit disappointed by that hyperlink. I was really hoping for a BBC food link to tell me a little bit about what a plum pudding actually is. Do students currently have any clue what a plum pudding is? Is it relevant outside of quite a niche, narrow aspect of culture? So teaching the Chinese students started me on a process of thinking about what I teach. And now this is best framed as decolonizing work, and to ensure that there's good representation of different contexts and ideas. So in Gopal's 2021 paper, there are a number of useful definitions for us. Decolonization is the end of rule by a foreign power and the recuperation and or formation of an independent entity. And by that definition, importantly, the people who were the colonizers can't really be decolonized. But we still have to address the legacy of the British Empire and of other Western aspects, and the impact that's had on science and the globe. Decolonizing the curriculum is then framed where an intellectually expansive curriculum that, taken as a whole, puts different ideas, texts and traditions in conversation, and the notion that that becomes more pedagogically sound. And I think that's a really useful framing for our thinking around this. We're trying through decolonization to create something that is more intellectually expansive and more pedagogically sound. So we can break decolonization into a series of questions. We can consider who is teaching. That could be the teaching staff, but it might also include guest lecturers. That can be a harder one to address because we do not always have the access or influence here. Other things that we do have the ability to consider: how are we teaching? Are we using active learning? Is it very passive? Is it very traditional? There's some papers out there that say that active learning can address awarding gaps, but that may be due to an increased time on task effect. There's lots of scope in here for good education research and scholarship. We can question what we're teaching. We can question whether that knowledge is essential. We can question the tradition of always teaching this part of chemistry or physics and that bit. And a lot of what we teach is governed by accreditation, and we can take a more critical reading of the accreditation guidelines that are often used to justify things we want to keep in a way that maybe they weren't intended. But we can also look at what our curriculum normalises. What is a chemist by that definition? And ultimately, what we're doing is questioning the power structures that we perpetrate. When we teach as we were taught, we are perpetrating a power structure. When we question an element of a curriculum, we are questioning the power structure that led to the development of that curriculum. But what decolonising is not is just as important. We're not talking about erasing cis white European men or any other source of knowledge from reading lists and teaching materials. And Gopal has views on this. A largely white or largely male curriculum is not politically incorrect as is often believed, but it's just intellectually unsound. Monocultures do not produce good thinking and are themselves a lethal form of unmarked narrow identity politics. Monocultures do not produce good thinking. So decolonising is not about stripping anyone from a curriculum, it's about broadening things. Decolonising can't be achieved just through an inclusive curriculum, but there are overlaps. You can have an inclusive curriculum and remain colonised. And it's also not quick, it's not easy, and there's still dispute over whether it's whether it is something that's necessary. But we don't have a chance right now to go into these debates. Chemistry is diverse. We know this from the nature of our undergraduate students, we know this from our staff. We also know that we have to tackle diversity. Chemistry could still be more diverse. So let's consider the laboratory class. What's the purpose of an undergraduate chem lab? Is it to teach and learn good lab practice, teach and learn scientific skills, acquire data for analysis for assessment, elucidate and explain key scientific concepts, give and acquire practical experience of lectured content, generate chemical waste, provide a venue for social interaction, build a sense of community? And so very, very often, an undergraduate lab is all 8 of those. The last 2 have been largely missing in 2021. Provide a venue for social interaction, build a sense of community. Labs are kind of integral to the sense of what it means to be a chemist. What happens if you can't attend a lab? Well, we all found that out in the past year, and it was a bit strange. Generate chemical waste is me with my sustainability hat on. Labs are very effective at generating chemical waste. One could argue that that's the major product. And it's ultimately quite a deep privilege to be able to handle pure chemical substances when you're a trainee in a discipline you may not make your career in. So that's labs. Back to this idea of diversity. Let's go back to diversity. So I've got some results from a recent small research study on the views of undergraduate chemical sciences students in decolonizing the curriculum. And we go into more detail on this in the poster session. So representations of scientists within my discipline reflect my background. The categories here are 1 to 4, and that represents typically white European ethnicities, and 5 to 18 represents all the rest. Those are the Office of National Statistics categories, and because we got quite a low sample size doing our study at the end of semester, splitting them into these 2 broad groups is the most logical course of action. So you can see that white European people are comparatively well represented in the curriculum, whereas there is no agreement among students from other backgrounds that the representations of science reflect their background. And one of the quotes from the interview part of our study was, "I can relate to British scientists and stuff like that because I'm British. It should make sense that if you're of Asian or African descent, that such scientists should also be present." So one of the key findings is that to a lot of our undergraduates, doing this, having broader representation, is like a no-brainer. So I have a challenge for you. It takes about 15 minutes to drink a tea or a coffee. Commit to spending that 15 minutes researching an idea, concept or scientist, and plan to spend 1 minute of your class time at some point in the next academic year talking about what you find. It might surprise you. We often get asked in decolonizing work to provide examples and things, but decolonizing is ultimately a mindset and it's a process that you have to go through. You have to start somewhere, so start by spending 15 minutes looking something up and seeing if you can change 1 minute of your teaching to address some of the ideas around decolonizing. And if we make progress with that, we'll start to make progress towards a chemistry that's fit for purpose in this century, not the past 2 centuries. Sivian and Talankar say that chemistry is the development and application of chemical knowledge and practices with the main intent of analysing, synthesising and transforming matter for practical purposes. None of this is changed through work like decolonizing, it's just made better. So from the survey that we did, we've drawn out some suggestions for teaching practice. First thing we're probably quite aware of is that subtitles and captions on recording teaching materials will aid comprehension, both from the point of view of students who may have disabilities of some kind, but also it will support our international students. We did also learn that with our Chinese students. We should incorporate global examples, case studies and perspectives into classes. Look twice as hard to find appropriate sources from a more diverse range of authors when we're citing literature. A few comments came out about students' unease at asking questions, so trying to create a supportive and comfortable environment is challenging. And this again is something we all know, we all strive to. Maybe we can try a little harder. We need to look at staff diversity, and we need to look at who we're inviting for seminars or guest lectures and use that as an opportunity to highlight a more diverse range of voices. But ultimately, we need to reflect on what we're teaching and why we're teaching it. Whenever we say, you can't be a chemistry graduate unless you've learned this, then we have to question why we're saying it. We have to justify those decisions. And often that's the kind of power structure that goes unchallenged. Now, one thing that's quite nice to do is to offer choice of assessment. So this can be done at 3 levels. You can offer choice within the assessment brief, you can offer choice of the topic that fulfills the brief and of the format that's used to fulfill the brief. So I've got an either-or assessment. So in our Sustainable Chem module, we used to offer our students a choice. They could either do the someone was wrong on the internet and find false or misleading science, or they could take down some fake news. And both pieces were written work, comparable length, comparable requirements for format and that. They just got a choice of which brief they followed. It's more common though to give choice within exams, either choice of question or choice within question, accepting that an exam question is a brief of sorts. Another common way we can do this is to give choice of topic. So we can give choice of example or context, and we can encourage students to select examples, products, contexts of relevance of interest to them. We can reassure them that we can tackle that kind of thing. We can give choice of subject, and in the Sustainable Chem module we have students produce an Education in Chemistry style magazine article, and we let them pick a topic of their choice. Solutions to problems are also a means of providing choice. So our Industrial Chem module students produce a feasibility study addressing a defined problem, but they have choice of the problem and they apply to that, and they also have choice of the solution. And then in the laboratory you might offer choice of a lab report of various experiments. We can also offer choice of format. So in the past I've run choice of poster or presentation in an organic chemistry module. When I run presentations these days, it's going to be the choice between in-person, online, or pre-recorded. And students can pick one according to their comfort zone. But we can mark all of these things in very similar ways. And for those magazine-style articles, we allow students to pick discursive, explainer, or creative non-fiction article styles. Creative non-fiction sounds a bit out there for chemistry, but it's just the style of popular science books. We also need to give students an insight into how research works, and we need to decolonise research and our thinking around it as much as we need to decolonise our curriculum. We need to make it clear who decides what research questions to ask and what research is funded, who holds the power there, and what ethical issues are there around the research questions that we ask. We need to normalise a research culture that includes participants from the countries or populations of study and values their input into research design and interpretation. It's more common for patients to be involved in medical research, but it's very common for people to work on new molecules to treat, for example, malaria or other mosquito-borne diseases without any real input or insight into the kind of countries that are impacted. Ultimately, decolonising is essential. The global challenges that humanity faces requires global perspectives and diverse voices. We are stronger through diversity. It's hard because at its heart, decolonising is about tackling power structures. It's about endlessly asking, but why? And power structures work in so many ways. Explicit ones are easy to root out. There's then the implicit ones, and then there's some that are just downright covert. We need to reconsider why we teach what we teach. And we need to consider the emphasis of our curriculum. What do we prioritise? But it's also worthwhile. We need to reconsider the context and content and assessment, and it will make our discipline more relevant and reflective of a global society. It will make it fit for this century. A couple of thoughts to leave you all with then. Normality is ultimately overrated. What is being normalised in your work area? Who are the people that are regarded as normal? And by that definition, who are being excluded from those spaces? As Vincent Rose notes, we need to reflect on what we commonly think of as a chemist, as well as the skills and knowledge that they hold. Are our definitions of normal fit for purpose anymore? Thank you very much.